Hi, the topic of this video is dot products. So I'm going to give you the definition first. So let's say we have two vectors, vector u, which has the components u1, u2, u3, and vector v, which has the components v1, v2, and v3. Then by definition, the dot product u dot v is equal to u1 v1 plus u2 v2 plus u3 v3. That's how we compute dot products. So why are we interested in dot products? It's because dot products have a very interesting theorem that says the dot product of two vectors is equal to the magnitude of each vector, magnitude of the first vector times the magnitude of the second vector times cosine the angle between the vectors. Theta is the angle between the two vectors. So using dot product, we can find the angle between two vectors. Let's have an example. Find the angle between vector u and vector v. U has the components 1, -2, -2. V has the components 6, 3, and 2. Okay. First, let me write the theorem. It says that u dot v is equal to the magnitude of u times the magnitude of v cosine theta. I can rewrite this by saying that cosine theta is equal to u dot v over the magnitude of u times the magnitude of v. Then I can say that theta is equal to cosine inverse of u dot v over the magnitude of u times the magnitude of v. I can compute the dot product. I can compute the magnitude of u and the magnitude of v. So let's actually do this. U dot v by definition is going to be 1 times 6 plus -2 times 3 plus -2 times 2. So this is 6, this is -6, they cancel, eventually we get -4. Magnitude of u is the square root of every component squared, so 1 plus 4 plus 4, square root of 9, which is going to be 3. Magnitude of v and the square root of 36 plus 9 plus 4 is equal to square root of 49, which is 7. Therefore, theta is equal to cosine inverse of u dot v, which we found to be -4, over the magnitude of u times the magnitude of v. So 3 times 7 equals cosine inverse of -4 over 21. And that's the final answer over here. One other cool thing we can use dot products for is that just by computing the dot product, we can immediately tell the type of the angle between two vectors. So let's say given two vectors, let's say u and v. If u dot v is bigger than 0, then the angle between the two vectors is an acute angle. If u dot v is equal to 0, then the angle is 90 degrees, so we say we have a right angle. If u dot v is less than 0, then we say we have an obtuse angle. And the reason this works is because, like, if you write down the formula, or if you write down the theorem, it says that u dot v is equal to the magnitude of u times the magnitude of v times cosine theta, the angle between them. This is always a positive value. This is always a positive value. Cosine theta, on the other hand, ranges between -1 and 1. So if you sketch the graph of cosine theta and make the angle range from 0 to 180 degrees, because that's the maximum angle we can find between any two vectors. If we draw two vectors, that's the maximum angle, 180 degrees. If you try and like keep moving the vector counterclockwise, like this way, well, the angle will be this angle over here. So it will be less than 180 degrees. 180 is the largest angle we can get between any two vectors. So if we have an acute angle, which means the angle lies between 0 and 90 degrees, we lie in this region over here, and the value of cosine theta ranges between 0 and 1. So if we have an acute angle, this is going to be a positive value, therefore u dot v is going to be bigger than 0. Now, if the angle is 90 degrees, which lies here, cosine theta is equal to 0, therefore a positive value times a positive value times 0, eventually we're going to get 0. So the product of two vectors which form a right angle is 0. And finally, if we have an obtuse angle, which means the angle ranges between 90 degrees and 180 degrees, cosine theta would have a negative value, and eventually the dot product would be negative. So that's a really cool thing we could use if we want to find the type of angle just by computing dot products. What else? Let me give you the properties. I'm not gonna prove any of them. You can do it yourselves. Most of them make sense just by looking at them, but if you want to prove them yourself, that would be a good exercise. Of dot products. Okay, so we said that the dot product of any two vectors is going to be a scalar quantity. Therefore, u dot v is the same as v dot u. The distribution rule works, so if we have u multiplied by a vector v plus vector w, we can rewrite this, dotted with u dot v plus u dot w. If you have 0 dotted with u, you're gonna get 0. And this makes sense because if we have a 0 vector, which is 0, 0, 0, dotted with any vector u1, u2, u3, you get 0 times u1, which is 0, plus 0 times u2, which is 0, plus 0 times u3, which is 0. So eventually you get 0. If you have a scalar times a vector dotted with another vector, you can just take the scalar out. So this could be c v. And finally, the dot product of two of the same vectors, like u dot u, is gonna give us magnitude of u squared. And this makes sense because we know that u dot v, that's just explanation here. We know that u dot v is the magnitude of u times the magnitude of v times cosine theta. So if they are the same vector, that means that the angle between them is 0 and cosine 0 is 1. So eventually you get u times u, magnitude of u times magnitude of u, which is just magnitude of u squared. So this makes sense. I guess that's it. If you have any questions, leave them down in the comment section below and I'll be more than happy to answer them. Good luck.